In this last lecture from Chapter C, we will learn about the shape of distributions and the means to detect outliers. Two of the most important and useful in the remainder of this course concepts are that of the z-score and the empirical rule. They allow us to make inference about normal distributions. More about this in Chapter 6. We talked in an earlier lecture about distribution shape and skewness. For most of the remainder of this course, we'll focus on symmetric distributions where the mean and the median are equal. We have already described less left-skewed distributions. Right-skewed distributions. And highly skewed distributions. There are calculations and measures of skewness which we won't get into in this course. Some examples of highly skewed distributions could be housing values, rents, or wages, salaries. Z-scores. These are often called the standardized values. A z-score is the measure of how many standard deviations a data value is away from the mean. The calculation is simple. A z-score is equal to any x value minus the mean of the distribution divided by the standard deviation. A negative z-score indicates a data point that is less than the mean. A positive score indicates greater than the mean. And a data value equal to the mean will have a z-score equal to 0. Now here is a general rule describing the width of a distribution when the shape of the original distribution is not known. Theorem provides a general rule for the number of data values that are within plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 4 standard deviations from the mean. When we know that the original distribution is bell-shaped and symmetric, not skewed, we can be more precise than Chebyshev's theorem and use the empirical rule. In future chapters, we will focus mainly on distributions like this, which we will call normal distributions. If we know the mean and the standard deviation of a bell-shaped distribution, we can state that 68% of the data values are within plus or minus 1 standard deviation of the mean, 95% within plus or minus 2, and over 99% within plus or minus deviations. This graphical representation of the empirical rules is something that you should remember, as it will give us a basis for Chapter 6 and calculating probabilities for continuous normal distributions. If we know the z-score of any data value in a distribution, there is a general rule that if that z-score is greater than +3 or less than -3, we can consider that data point to be an outlier. An outlier could be incorrectly recorded, something which didn't belong in the data set, or some extreme value which we may want to eliminate from study. A simple means of describing any data distribution could be the use of the 5-number summary. The 5-number summary is pretty straightforward. The smallest value, the first quartile, the median, the third quartile, and the largest value. The 5-number summary uses values that we've already learned. And a box plot, which is well described in the text, is a way to describe that 5-number summary on a chart.